Good morning to all of you, friends, colleagues, industry experts. Today marks a momentous day for us at Applied Micro. And it also marks a momentous day for the cloud infrastructure in general. And I'd like to start by saying that what you're about to experience today has three fundamental ingredients: the infrastructure, ARM, and us at Applied Micro. And I'm really excited today because it also marks the start of a new Applied Micro, and you'll start to see what we've done front and center to really disrupt the cloud infrastructure. So let me get started by first recognizing the distinguished group of panelists today and speakers. I'd like to start by, please give them a hand, Lance Howard at ARM, EVP. Dr. Christos Kozirakis, Stanford Prof. Mr. Andrew Feldman, founder and CEO of C-Micro. Vinay Rovuri runs our processor business. John Masters from Red Hat. So, without further ado, let me get started. I don't want to take away from the most exciting part of today's presentation, so let me set some context. Let me take you back a decade ago. A decade ago, you had computing and communications work as two different clusters in the infrastructure. So, what was computing all about? Well, computing was about structured Oracle-like databases, related sets of data, very ordered, very centralized. What was communications about? Well, primarily a TDM network, some IP, much more one-to-one, and 1 gig was a big deal 10 years ago. By the way, Applied Micro, you know us to participate in the communications market. We drive a lot of the innovations in WAN and data center infrastructure on the comm side, and we're a small player in the embedded computing side. Well, let's fast forward to today, a decade later, and we've seen these two clusters in the infrastructure come together into what we know and what we love as the cloud. So there have been pioneers in the cloud: Amazon, Yahoo, Microsoft, Google, and Apple. And well, what are the characteristics of the cloud? Well, we've gone from structured data, very crisp, related data, to big unstructured data. We've gone from a very closeted, closed ecosystem, centralized, to something that's much more open. 10 and 100 gig interfaces are lingua franca. Nobody ever talks about 1 gig anymore. And the cloud resembles our societal interactions. It's a fundamentally one-to-many infrastructure. Well, if I were to go off and look at what is the fundamental metric that is axiomatic in terms of scaling and sustaining the infrastructure as we know it today in the cloud, it all comes back to something so fundamental, which is energy and dollars. So I want to recognize our friends at the Electric Power Research Institute, Mr. Szymanski. Dennis is here in the audience. Thank you, Dennis. And EPRI does a phenomenal job. They're nonprofit. They have no axe to grind. They're the guardians of accuracy relative to energy, its consumption, specifically related to data centers and in the cloud. So Dennis gave us some data, which is very telling. And the graph is fairly simple to understand. On the x-axis, you have efficiency, how efficiently you're using power. On the y-axis is how much power are you using. So let's take a look. If you look at the big guys, the guys whose P&L depends on infrastructure, it's the Googles, the Amazons, the Facebooks, the Apples. Well, they're highly efficient. They are very efficient. They build their own data centers. They architect them from grounds up. And by the way, they use a boatload of power, massive amounts of power, megawatts of power. And now you would think that, well, they're the big guys. Well, they are big, but they are the minority in the infrastructure today. The majority of the infrastructure, which are guys who run big hotel chains, guys like Starbucks, they don't have their own data centers. Well, what do? They essentially outsource their infrastructure, and they do not control their efficiency in terms of building their own infrastructure. So you have 2 megawatt consumers of energy driving the infrastructure. And by the way, this stuff is growing at an alarming rate. Highly inefficient, high power. Very efficient, high power. So what is the highest common denominator here? High power, high TCO. So, well, we looked at it and we said, well, what would fundamentally change the infrastructure? What would make us really make a huge dent into this infrastructure? Well, thanks to the data from EPRI, and we listened to customers starting 3 years ago, and they kept whispering. The whisper turned into a shout. The shout turned into banging a desk. And here we are 3 years later. We're on the cusp of something beautiful and phenomenal. We have a way to fundamentally change the TCO, the sustainability coefficient in scaling this infrastructure. So, what do we need to do? Well, what is the most obvious thing to do? Attack the source of the TCO runaway, which is go and rethink a server. Go and rethink a server. Let me say it for the third time. Go and rethink a server, because that is the lowest hanging fruit in the infrastructure. So we did. We said, well, what if we go and rethink everything grounds up? Well, it is our target today to demonstrate to you that we can significantly change the infrastructure, and we're on the cusp of doing this in an unprecedented fashion. So without further ado, let me first congratulate Lance. Today has been a momentous day for ARM, 64-bit. And turn it over to Lance to tell you about ARM and their big contribution to this solution.
Thank you, Paramesh. So what a day. I mean, as EVP of Marketing at ARM, I am responsible for running the TechCon event. And as you can imagine, this morning has been quite an exciting time, both with the announcement of the V8 architecture from ARM, but also then quickly followed up by this very key event here with Applied Micro. In fact, thank you for inviting me. It's an honor to be here working with one of our lead licensees, and it's a great privilege. So thank you for that. What I want to do is give you a very short couple of slides perspective from ARM of why we think this is such an exciting opportunity for both ARM and our partners, and in changing the landscape of server technology. So, as Paramesh very clearly articulated, a lot of this is around total cost of ownership. And what that comes down to is, capital infrastructure in terms of expenditure, in terms of purchasing chips and building the servers. But actually, the main cost in servers comes from the energy consumption. Energy consumption consumed by the SoCs in that server, but also the energy consumption consumed in keeping the things cool enough such that they don't overheat. So we think there's a real opportunity here that building on the low-power heritage of the ARM architecture to fundamentally change the server market. And we believe that using the scalability and low-power SoC solutions based on the ARM architecture, we can significantly reduce the energy consumption in servers and therefore reduce the total cost of ownership. I wanted to talk a little bit around our perspective on the evolution of servers and why the time is now right for that or the ARM architecture to make a significant impact in server technology. Paramesh talked about the old days of where there was very large structured databases based on enterprise servers, and essentially they were kind of running within an enterprise, but not really servicing the cloud. And there you had sort of single applications on very large monolithic sort of server architectures using very large CPUs. And then a lot came along, the whole idea of sort of cloud computing and servers for the cloud. And what we started to see was that the tasks and loads on servers began to change in their nature. And we moved from this, rather running a single application on a large sort of server box, we moved into this situation whereby we have enterprise applications, cloud applications running on a server, and underpinning that was the need for virtualization. So the virtualization technology allowed us to run multiple sessions on a single server architecture. So the strange thing about that is then that began to partition, if you like, or segment the workloads within the server. And that then meant it was very amenable to applying across multiple CPUs implementations, multi-core implementations. And that's where we begin to see the ARM architecture really playing out. We can build large server capabilities with multi-core approaches based on the ARM architecture. And we believe that if you use those smaller, more energy-efficient building blocks, that you will actually realize these significant energy savings in a server. And if I then was to project into the future where we might end up, then I think as we look out over the next sort of 7 years or so, you'll again see another evolution in server technology where you'll start to see different types of processing engines. It won't just be CPU technology, multi-core CPU technology, but you'll start to see different processing engines integrated into servers to handle specific tasks. So we've been working with Applied Micro since early part of 2009. They are our lead licensee for the V8 architecture, named, as I say, and covered in the press release. And we got very excited about working with Applied just because of their vision and where they wanted to take server technology. And we recognized that sort of matched our own view of the world. So what we have announced today in terms of the V8 architecture launch, but also then in terms of what we're announcing here with Paramesh and Applied Micro, is not something that's just kind of materialized in the last couple of months. This has been years of partnership, years of working together to get to this point. In our sort of timeline here, what we're showing is sort of, the investment in the ARM architecture, as I say, sort of going back to sort of the early days of 2007, 2008, and how we think that sort of pans out in terms of availability of technology and moving into when will we see first prototypes of server-based technology, 64-bit server-based technology based on the ARM. Well, our big job is around ecosystem development, and we're already investing today with a number of our partners, and sort of in particular, they're sort of Canonical recently announced the availability of the first sort of Linux commercial available Linux Enterprise Edition. We're also working very heavily with people like Oracle in terms of their JIT technology to support enterprise, and they recently highlighted and demonstrated some prototype working they've been doing of their C2 JIT for the ARM architecture. So lots of investment going on in this area. And we're very pleased to be sort of working alongside Applied in realizing our shared vision of delivering much greater power and energy efficiency into the server market. So at that point, I think I'll hand back to Paramesh. Thank you.
Well, thank you so much, Lance. And I'd like to invite Dr. Christos Kozirakis from Stanford to give you a very, very interesting perspective on rethinking a cloud server.
Good morning, everybody. It's a pleasure to be here today and share a few thoughts about where next generation data centers are heading towards and what's the role of hardware in this vision. And hopefully we'll get slides on at some point. Oh, just have to click. All right, there you go. So the drivers for data centers are relatively straightforward. We want larger scale because we want to be able to put more services online, host more data, and host more users. And there are also some very interesting economies of scales that kick in when you go from the 2-megawatt facility to the 10, 20, 40-megawatt facility. We also want performance because we want to have fast reply for all these user queries, and we want to have a rich experience. Queries are getting more and more complicated, but we want them to be as fast as they've ever been. And then finally, we're going to be a low-cost data center, and that implies two things. One is low capital expenses, but also low operational expenses. So it better be lower power. So if you look at what has been happening for the most part in the industry the past 10 years, there's been a lot of focus on what's called the PUE, the power usage effectiveness. So the basic idea is how do we make sure that for every watt that we bring into the server, we don't waste too much power into providing the power delivery or providing cooling. And the initial picture was really bad. For every watt you had to put on a server, you were spending about 2 watts in cooling and power delivery. That was very inefficient, PUE of about 3. There's been a lot of work with many very interesting techniques on both sides. For example, in power delivery, there's been a huge reduction in the number of conversions that you do between the electricity plant and the servers. And in the case of cooling, we've seen some really interesting ideas, some of them as simple as open the window to get cool air inside as opposed to use air conditioning. So if you look at the best practices allowed these days, you can do a new facility which has a PUE of about 1.1. So there's a 10% tax to feeding the servers. So even though we still have to convince most of the industry to adopt these techniques, the problem is somewhat solved. So if we look at what are the current challenges, they're slightly different. Once you fix the surrounding infrastructure, power delivery and cooling, the problem is the server. So you have to go back in and say that 1 watt that goes into the server, what do I get in return? What's the energy efficiency of the server to begin with? Am I getting the most out of that watt, or am I wasting half of it in the server? Okay? Now, the second thing that you want to do is increase the hardware utilization. If you look at most of the servers in data centers, the utilization is 20% or below. And in some cases, it's because it's the middle of the night and there's nobody searching for anything. But in some other cases, it's because we cannot multiplex workloads on a single server because we're worried about interactions. We're worried that the load from the one service will impact the latency of the other one, even though if you add them together, they're below 50% utilization. And then finally, we want to reduce latency. If you look at most of the interesting things around social networks or any other kind of exciting application, it's all about fast reply to queries as opposed to throughput computing, number crunching overnight. So we want to make sure that whatever happens, the user experience stays the same, so you have very fast access to huge amounts of data. So what can hardware do here? There is a lot that you have to do in the whole stack, hardware and software, server infrastructure and the whole data center infrastructure. But there are a few things that come directly from the hardware itself. The one very important thing is integration, bringing together cores, memory controllers, which we already have, networking, high-end, 10 gig, and I/O. And this is not just a game about bringing everything together, reduce the components, save a little bit of power on the interconnect between the two. This is fundamentally changing the kind of latency I can provide with respect to I/O access. It's also changing the kind of quality of service I can guarantee about the interactions between the processing and the I/O. So I can talk about the 99th percentile latency and the 95th percentile latency of accessing my I/O devices with some confidence without worrying too much about some strange interaction between components that were never designed together. The second very interesting thing is efficient out-of-order cores. The industry has been consumed for a long time in this debate between do we still use those high-end cores that we have in data centers today, or do we switch to this very simple, single-issue, in-order, wimpy cores, as some people call them? And of course, there's nothing that's perfect. Okay? The high-end cores are very power-hungry. The low-end cores do not provide enough power. What's interesting is being able to bring engines which are somewhere in the middle. Something that basically brings good performance at some reasonable power consumption, so you can get the best of both worlds. And then the final thing that hardware can do is provide more support for virtualization. In that way, you can multiplex multiple servers together while still being able to argue about the latency in their interactions. So that you can increase utilization and get the most out of the 1 watt that you're plugging into your server. Thank you.
So much. Well, thanks so much, Christos. And now we get to hear from a guy who actually builds real servers. Andrew.
How you doing? If I'd have taken Christos's class, I might have started this company earlier. Because I don't have much left to say after that. Everything he said is right. We set out to build a company around a single value proposition that we could build servers that solve the energy and the space issues in the data center. And to that end, we've built servers that use 1/4 the power and take 1/6 the space using exactly the techniques that Christos just mentioned. We're plug and play. We require no modifications whatsoever to software. We asked ourselves a similar question 4 years ago when we were starting the company, a question that has been touched on here. It's, why did power suddenly come to the forefront? of our discussions. 10 years ago, when I look around this room, most of us were in the industry 10 years ago. 10 years ago, we weren't talking about power in the data center. Right, why now? What's happened? What changes underlie, all right, the rise to the forefront of power? And what happened is our data centers changed their jobs. Right? Data centers used to be for employees. Right? They used to be for internal compute. And when they were for internal corporate compute, the actual number of problems being worked on was small. The compute was large and complex. We use the term structured here. It was organized. The problems were complex and they were interrelated. As a result, they were easy to schedule. Compute resources could be fully occupied. Why? Because you can tell your employees, and you've all been told this in your lives, why? Wait. Wait. You know, I need 10 new servers, 2 weeks. Right? I need this analysis completed tomorrow. All right, and what changed in all of this was the internet delivered a very different type of role for the data center. Whereas before the data center was focused at your employees, today it's focused at your customer. And what don't we tell customers? Wait. All right? And so the result is we went from having a relatively small number of workloads to a huge number of workloads. We went from large, complex, interrelated, but well-structured data to small, simple, independent, and completely unstructured data. We went from something that was easy to schedule, where the people worked for us and we could say, hey, wait, to an environment where traffic is bursty, and as a result, servers live in low utilization or in idle. What happened was the work changed and servers didn't, and that created the power problem. Volume servers today are punishingly inefficient in the exact small, simple workloads that drive today's work. Volume servers are extremely inefficient when running at low utilization. At zero utilization, today's best-in-class rack server consumes about 2/3 of the power it consumes at 100% utilization. So as we mentioned, at 4 in the morning when your servers are doing nothing, your OpEx is ticking away. Right, as 2/3 of the power is being consumed. And it was this mismatch, this failure of servers to evolve to match the evolution of work that caused the power issue in the data center that we're so interested in solving today. And for us, it created an opportunity we believe is on the order of $15 billion in servers. So our market insights were several, and they've been touched upon here in different ways. First, that today's servers were not aligned with this fastest growing part of the workload. Let me give you an example. It took 130 years for JP Morgan Chase to become one of the largest consumers of CPUs in the world. All right? It took Facebook 4 years from start to finish. Right. That's this. That is that servers are no longer aligned with this fast-growing workload. Small, simple CPUs improve compute per unit power. And finally, and this was, I think, Christos's point also, that you can't rely on the CPU as a server vendor. Right? You have to work on everything else. And at C-Micro, that's what we've done. We've built a single-box cluster computer. It's CPU independent. So we can run x86 machines. We can run ARM machines. We can run any processor. Today, we build with the most efficient CPU available, which is Intel's Atom, and that's why we're so excited about being invited here today. It's because we are actively seeking and driving the industry to deliver to us, right, more power-efficient processors, processors that do more work and consume less power. We also invented technology that allows us to remove 90% of the components that live on a motherboard. We shrink a motherboard to the size of a business card. Then we invented technology that allowed us to tie together hundreds of these business cards for pennies a gigabit with exceptionally low latency and for very, very little power. Now, when we look forward, the result is for us a system that replaces 60 traditional servers. It replaces their disk, it replaces the Cisco switches, it replaces the terminal servers, it replaces the load balancers, and it does all of that in 10 rack units. So today, with today's technology, not the cool technology that we're hearing about in this meeting, but with today's technology, in 10 rack units, we deliver 768 cores. It draws a quarter of the power. It uses a sixth the space, and it weighs a third as much. We're dazzled by what we could do with the technology here. When we look forward, we ask the industry, all right, and our friends at Applied Micro have answered, we ask the industry, we're looking for more performance per watt. We're looking for a lower price per unit compute. We're looking to support more memory, all right, and that demands 64-bit support. We're looking to support other technologies on the motherboard that allow us to build a system that is low power. It's not enough if your part pawns off extra work and energy elsewhere. So you have to support low power DIMMs. And finally, you need an SoC because it's our intention to pack as much processing capability as we can in a given footprint. And these are exactly the items that Applied Micro heard from their customers. They heard from Christos, and around which they've built their system. Thank you.
So here we are, 3 years in the making. Lots of blood, sweat, and tears. I want to kind of recap what the vector was when we started 3 years ago. So by this time, everybody in the room should know what TCO is. So let me start there. The absolute metric to sustain cloud infrastructure growth has to do with TCO. And the only fundamental thing that we can change is rethinking servers. And the only fundamental thing in a server that we can change that give us the maximum bang for the buck is the silicon. So we need to vector into revolutionary server silicon. And what you're going to see going forward is that's exactly what we did. Every one of our tier 1 customers said, guys, you need to rethink this grounds up. So let me draw you an interesting analogy. When we started this, we said zero compromise. I think you've heard this. No wimpy cores, no wimpy fabric. Zero compromise, guys. Zero compromise. They said, do not start with the legacy. Shed the baggage. Zero compromise. Clean slate. We do not want you to trade off the wrong things because that's not what is going to be required for the 21st century cloud. We listened. And the way one of our customers put it to us, very interestingly, was he said, well, guys, this thing that I hold in my hand, 1 billion of these are what make you experience today's cloud infrastructure. Is there any way you can take the DNA in this and move it into the infrastructure? So it was just not us thinking about this, but the customer base resoundingly told us that they're done dealing with an architecture that was conceived in 1981, 86, that has got 30 years of baggage, 30 years of, I need to be compatible, more silicon area, more power. You can't shed that easily. And so we went to our friends in Cambridge, and we said, well, we have this thing called a server. And they said, well, we know about it. What do we need to do? Or what if we were to take all of the clean slate thinking, ARM comes from clean slate thinking. What if we were to take all of that clean slate thinking, and to Christos's point and to Andrew's point, no wimpy cores, brawny stuff, grounds up, microarchitecture from scratch. What if we were to combine those two things? So we were to take the world's most pervasive ISA, 64-bit, to make sure that it's real. It's not stuff that cannot run mainstream workloads for the cloud infrastructure. And then we do something that Applied Micro is good at. Really integrate the heck out of stuff. Unprecedented breakthrough integration. Mixed signal, 40 gig, 100 gig, SerDes, the whole 9 yards. Bring it all together. And tap into the massive ecosystem that ARM has seeded and has been so successful at seeding over the last 2 decades. Well, what do we get? We get an absolutely clean slate design for a revolutionary server platform. Well, ladies and gentlemen, this morning, I would like to introduce you to XGene. So let's start by looking at what powers XGene. Remember, clean slate, no performance compromise, no power compromise. Grounds up, world's first 64-bit high-performance V8 core. By the way, we didn't aim for 1, we didn't aim for 2, we aimed for 3 gigahertz from the get-go. No wimpy cores. Then what did we do? Well, we didn't say we're going to do the legacy way. We said we were going to go fully superscalar, quad issue, out-of-order machine, a real computer. This is not a wimpy computer. This is ARM on steroids. Okay? Then we said, well, we can't just stop there because we want to do this clean slate. We don't want to keep adding incrementally. Full CPU and I/O virtualization from get-go. And by the way, a lot of credit to Muller and the ARM folks and Lance and Warren, because ARM started with a clean slate. Very, very, very critical. And finally, real server class features. What I show to you today is a die microphotograph of the world's first 64-bit 3 gigahertz ARM core. Ladies and gentlemen. We didn't stop there. We said we need to take this to the next level. We really need to revolutionize a server platform. What did we do? Well, we said we can't have 2, we can't have 4. We need to have a reasonable amount of sizing relative to the number of cores we can support. So we built a multi-terabit coherent interconnect that scales on silicon and off silicon. Our coherent interconnect supports up to 128 cores in one coherent domain. This is unprecedented computing power. Performance at the lowest power. Performance at the lowest power. Unprecedented memory bandwidth, almost 80 gigabytes per second in our first SoC. Fully non-blocking QoS. Extremely low latency. No more wait. You're going to see stuff that's going to blow you away. And then we didn't stop there. We said we really need to re-engineer the entire server platform. And we took Christos's class and took it very seriously. By the way, our customers pretty much agree with him 100%. We said we need to take the heterogeneous traffic workloads that exist, bursty, heterogeneous traffic, and implant a bunch of really sophisticated ARM-based accelerators on the same die. That is unprecedented in the server space today. It has not even been conceived of. And finally, we did what Applied Micro has made lots of money doing. We brought our bleeding edge 10, 40, 100 gig DSP and mixed signal expertise to add all of the communications infrastructure onto the same platform. We build 10 gig, 40 gig, and 100 gig communications today for the data center. We put it all together. So we really re-engineered the server. So what does this do? What is the system impact of something like this? Well, you can actually imagine a 1,000,000 session 1RU fanless server in the very near future. And Andrew will be happy to provide you chips. You can actually get to an order of magnitude reduction in TCO. And finally, you get denser, smaller, and cooler. So we stand on the shoulders of giants today, and we've truly changed the infrastructure. Now, this is PowerPoint. This is all talk. Well, not quite. We have XGene running here today live. So I'm going to hand it over to Vinay to bring you face-to-face with XGene. Vinay.
Thanks, Parmesh. So I get to have fun. I actually get to show off the stuff that we have been working on for 3 years. So before I actually get to the actual demo, I want to talk to you a little bit about how we got started on this front. About 3 years ago, as Parmesh mentioned, we had conceived this idea of, let's go build a server. What does that really mean? So we've talked to customers. They said exactly what Parmesh just mentioned. No compromise. Don't compromise. Don't get bogged down with legacy. So we said, what else? What else do we do? We looked at, he said, go build the best server on a chip you can get. What do you mean by that? It's not just chips. Think platform. Think systems. So that's exactly what we did. We examined hundreds of systems out there. How are they built? Take the best of breed. Take into consideration power. Take into consideration performance. Take into consideration integration. We did all that. We took hundreds of components and integrated into a single silicon, making it a true server system on a chip. So we started, of course, the most important part of that SoC is the brains, the CPU. We looked at multiple architectures, multiple vendors, multiple everything, and we said the best way to go about it is grounds up, build your own, and we picked ARM. ARM because clean slate, that's new technology, brand new specification, you build on giants. That was very nicely done. And then we didn't just stop there. We wanted to see, well, what do you integrate? You have to integrate the system. So we looked at the cloud. We looked at what are the relevant IOs. So we optimally composed all of that and integrated that into a nice silicon. Well, we didn't just stop there. Virtualization is really important for server space. So we took the best of breed CPU and IO virtualization, put that together. And you can't just stop there. Have to have a really strong ecosystem to support it. So we had all of this in mind and all these partners working together when we came up with XGene. So we also didn't want to just make silicon and have our customers and partners wait for silicon, because that takes time, especially something as groundbreaking as this. So one of the things that we did was we said, we want to have a platform for our partners and customers to play with and to run software and write software with. So we thought this through well ahead of this project, and said, we're going to take the SoC itself and map this onto an FPGA platform so that we could actually sample what looks almost like the real silicon. So to that, we took the same exact design that will soon be available in silicon and mapped it into this FPGA system. It's the same 3 gigahertz cores, out-of-order superscalar that you just heard about. We didn't take one core. We integrated multiple of those cores into the system. We didn't just stop there. Fabric is really important. For anyone that knows servers and SoCs, fabric is key. So we took the fabric and integrated that as well. into this system. Low latency, same exact design. No compromise. No compromise. That was our mantra. No compromise. And this fabric not only just interconnects CPUs together, but it actually interconnects multiple chips together. Well, we didn't stop there. What's a system without I/O? So we took, again, the same way, best of breed. What are the most important I/O for cloud? You have to have PCIe, you have to have Ethernet, and some sort of storage. So we've taken those peripherals and put them into the FPGA as well. Well, this is almost looking like a real chip now. Well, guess what? Not yet, because that's just hardware. You need, for a system to be truly system, you need software. So we went to the next step. Said, well, what's good software for the cloud? Some of you might have heard of LAMP, and I'll describe some of this. Linux needs no introduction. That's the operating system. Web server is synonymous with the cloud. You have to have a web server. That's how you access it. So we've integrated Apache Web Server onto it. You have to have some sort of database running on it. MySQL, very common in the cloud today. We've integrated that. Well, you need a programming language. PHP is language of choice for the cloud today. So we've integrated that. That's what LAMP is. And all of that ported onto this platform again. Well, that's the definition. Let's see this thing in action. So what you see here is an actual console port of the system I just described. It's actually running in the back. And I'm going to show this to you live. This is live. The window with yellow text here is a console port of the system. It's the interface to it. So I'll fire this up. So while this thing boots, what you're seeing in front of you right now is world's first 64-bit ARM Linux running on the world's first ARM 64-bit hardware. Never, ever done before. Ever. First time. Ladies and gentlemen, I give you X gene. So I just typed a simple command. No compromise also means you can't make things proprietary, because you can build the best technology in the world, and if you make it proprietary, nobody will buy it. That's the truth. So what we did was we took open source. And what you see over there is open source Linux. In fact, this is 2.6.38, latest Linux from kernel.org. We downloaded it. All we did was, with the help of ARM, added ARM 64-bit support to it. Toolchain, same exact thing. Compiler and such, downloaded it, added 64-bit ARM support to it. And voila, you have a standards-based operating system that ecosystem can support. What this means is, eventually, this will go up into open source. Partners and customers can download this from their GNU website, and off they go. They don't have to do anything special, anything different from what they're doing in terms of development. That's the key, to keep that simple and keep it the way they like it. Okay, switch back. So when we started this platform, this development of this platform, we wanted to make this available to customers well ahead of silicon. It was necessary because they need time to develop stuff so that when silicon is available, they can deploy it right away. not wait for another year? Well, this is going to be available in 2 months from now, January 2012. In fact, some of the guests that you have in the audience will be getting some of these FPGA boards. There has been tremendous traction for this from customers and partners alike. So 1 year is a good time for us to make this available. Well, that's exactly what we did. Silicon is available in less than a year from now. This is a proud moment for us, to be the world's first, not only implementers of 64-bit, but to sample silicon in less than a year from now. You will have an alternative. It's true 64-bit Linux server technology outside of the status quo, as Paramesh mentioned. So with that, I want to talk a little bit about ecosystem. Ecosystem is very, very important. That what makes or breaks anything, really. You have to have the ecosystem supporting you. The cloud is synonymous with Linux. And Linux is key. For ages, for years, as you know, Red Hat has been synonymous with Linux. So we thought, why not have Red Hat come and say a few words about what they think of this? I introduce you to John Masters.
Thank you, Vinay. Is this on? You guys hear me? Excellent. Thank you very much, Vinay. That was something else, right? Let's give him another round of applause for that. That's awesome. And mine's going to be in the mail, right? So come January, I'm going to have one, right? Right. So just before I get started, I want to just remark that it's something interesting here, that there's an assumption going in that it's Linux, right? An assumption. I was pointed out to me yesterday by Vinay. I just assumed Linux was the first thing you guys were going to put on there, right? Great other operating systems out there, but Linux was I just assumed. And I'd like to, before I start, just thank ARM. Well done. Very, very good to see that V8 announcement today. And Richard, I'm very looking forward to coming to your talk later on today as well on the architecture. So I'm John Masters. I'm a principal software engineer with Red Hat. I have many different hats. Some of them are red. And I'd like to thank Applied Micro for inviting me to come and speak to you a little bit on this panel today. What I'm doing here is representing Fedora Linux, which is the Fedora project, which is an open source Linux distribution sponsored by Red Hat, and in particular, the Fedora ARM project, which is part of the Fedora project working on ARM devices. And, you know, ARM's been an emerging technology for quite some time. We've seen it grow up from, you know, small embedded devices, and it's now starting to make inroads into the server market. This is all very interesting stuff. You start to hear words like server on chip, right? It used to be system on chip, now it's server on chip. So you have this ongoing integration of traditionally offloaded features being pulled in onto the chip. And also rationalization of distributed resources. So, you know, where I see a lot of ARM success in the future in this space, in the server space in particular, is going to be in low-power, high-density cloud servers, and using things like pulling the fabric in, integrating that into the chip, having a really compelling server-on-chip design. Coupling that with physicalization and virtualization. So you'll virtualize resources, but you'll also distribute them out physically amongst many thousands of cores. So where does Red Hat and Fedora fit into this? Well, the Fedora ARM project has been going for about 4 years now. We have great support for ARMv8 and ARMv7 in the latest release, Fedora 15. As a cutting-edge Linux distribution, we're always looking to the future, you know? And so we've been tracking ARMv8 for a little while, right? We had a heads up. And we very much look forward to supporting V8 in the future. So that's going to be awesome. We have a couple of challenges ahead. Some of them are around platform standardization, operating system standardization. I also wear an open source hat. And for me, the world is bigger than any one Linux distribution or anything like this. I'm very much interested in platform standardization and compatibility of software. So that's going to be a key driver for me going forward, is to work with ARM and with other folks in the industry to solve some of the standardization issues. So in summary, thank you very much for inviting me here. We look forward very much to working with you in the Fedora space. I'd love to see Fedora booting next time you guys give a demo. Thank you very much, and I'll hand back to Paramesh. There you go. Oh, yeah,
thank you.
Thanks.
Thanks so much, John, and thanks to all of us who spoke today. We are truly at a crossroads for the infrastructure, and before I leave the context of ecosystem partners, I do want to recognize our friends at Canonical. So they have, in fact, I believe today announced a specific 32-bit Linux package for servers. They've done a fantastic job, and we're working with them as well. We want to make sure that they are recognized. We really, really value the relationship with the ecosystem and with ARM. And so just wanted to make sure that we're not polarized, or we're not seen as polarized. So again, thank you, Canonical and Ubuntu as well, for helping us out. So, what is the capstone of today's message? I like to look at this in terms of the cash register ringing in the cloud, the TCO cash register. So by the time we've done with this, I think between Christos, Andrew, Lance, and all of us, we've basically probably contributed in no small part to the massive amounts of data that have transitioned in and out of the cloud. Now, just to let you know, every day there is an increment of 95 million, incremental $95 million of TCO spent in the cloud infrastructure. Incremental $95 million a day. Well, 6x increase in 4 years is what the most conservative estimates say. Well, we've taken a giant step towards taking a large, big bite out of this. And with our technology that we unveiled today, it is my firm belief that we are going to take a nice 30% chunk out of this going forward because of the revolutionary silicon server platform that we are introducing with ARM's V8 architecture. So to recap, we've lost all the legacy baggage. 31-year-old technology is no longer applicable to the infrastructure. We have broken and shattered the performance and the power barrier. Grounds up, big brawny, 64-bit X-Gene CPU core, complete suite of I/O integrated, phenomenal amount of network and application acceleration on one single die. You saw it live today. It's no more PowerPoint. We're at the cusp of taking a truly revolutionary step for the market. I want to thank all of the Applied Micro folks who made this happen. They worked very, very hard. Some of them are in the audience, but they have had a huge part to play in getting their heads down and making this happen. I'd like to get a hand for our company. Finally, how does this change Applied Micro? You know us to be a transport company, maybe a tiny embedded processor company. Well, today we have put ourselves front and center into being the leader, the market first, world's first, market first, revolutionary cloud server silicon platform provider, bar none. It's changed our entire addressable market to be roughly $6 billion from where it was. It's almost a tripling of the addressable market from our company's point of view. We have a full revolutionary cloud product portfolio. We are not a point company anymore. We're not just an OTN player anymore, for those of you who know us. And what do we bring to the party? Well, we are starting a new party today. And it's to basically dismantle legacy thinking and dismantle the status quo. We have products that span everything from fiber in the front end of the data center to products that drive backplanes. We have now added the most compelling element to our portfolio, the most disruptive computing element on the planet, which is ARM's v8 based 64-bit CPU. So I stand very proud today, and I'm really, really, really happy and really excited that all of you could join me for the event this morning. I want to thank Lance, Christos, Andrew, and John, and all of our partners for being here. This ends the live portion of our webcast. Please join us afterwards for Q&A. Thank you.